Hi everyone. So in today's exercise we need to show that the integral that goes from minus a to a of 1 over 1 plus e to the power x dx is equal to a. So to solve this, first thing first, we need to consider the indefinite integral. So let's remove minus a, and we just try to solve this integral. So to show this, we're gonna start from the left hand side, and our goal is to find a. We have this integral. How we would solve this? We would use here, let's use the substitution method. So if we substitute u to be 1 plus e to the power x, then we have du dx, which is the derivative of u with respect to x. This would give us e to the power x, because the derivative of 1 would be 0, and the derivative of e to the power x is e to the power x. Now if you cross multiply, we're gonna have du is equal to e to the power x dx. Now from this, our dx, we divide both sides by e to the power x, would be du over e to the power x, which is the same as e to the power minus x du. So from this we can now substitute. So we're gonna have integral of 1 over, instead of 1 plus, instead of this we substitute it to be u. So we're gonna have 1 over u, and instead of dx we're gonna have this, because we said that dx is equal to this. So times e to the power minus x du. But as you can see, our goal was to get rid of x and have only u, but here we have e to the power minus x, so we need to do something else. If we consider this one here, let me put it here. So if we take this means we take 1 to the other side, so e to the power x would be equal to u minus 1, and now e to the power minus x would be 1 over e to the power x, right? So 1 over e to the power x would be 1 over u minus 1 from this. So instead of having this, we can just write this. So then we're gonna have integral of 1 over u times 1 over u minus 1 du. Now it's nicer because we have only u, so we can write it down as a single fraction. So u times u minus 1 du, right? So this would be the integral we need to solve. Basically, we have used the substitution method, but we haven't solved the integral yet. So to solve this, we would use a different technique. So we would use the integration by partial fraction, right? So this would give us, so if we take this fraction here, our goal is to write it down as partial fraction. So we're gonna write this as the sum of some fractions. So this would be some a over u plus some b over u minus 1. Now if we make a single denominator, we're gonna have u minus 1 here, and then the numerator would be a times u minus 1 plus b times u, basically. So then we can copy the denominator, and the denominator should be equal to 1, because you see this denominator should be equal to the numerator. We can copy the numerator, and this numerator should be equal to 1. Now what we're gonna do, we can expand the left hand side. So this implies we're gonna have au minus a, then we're gonna have plus bu is equal to 1. Now what we're gonna do, we're gonna collect u, and then we're gonna be left with a plus b, because we take u from both this and this, and then minus a, isn't it? Yeah, this is equal to 1. Now actually there is no need to do this. From here, if we let u to be 0, so if u is 0, then what we're gonna have, minus a is equal to 1, which means a is equal to minus 1. Now if u is 1, basically this would be 0, right? So we're just gonna be left with b. So b would be equal to 1, basically. So what we wanted to write was this, so we can just copy it and then substitute a and b. So we have a to be minus 1 and b to be 1. So this is, we have written this one here as the sum of two fractions. So we can write this integral as the integral of this with respect to u. So from here I would just come here. So our integral is the integral of this one here with respect to u du. Now this is equal to, we take the minus outside, so this is minus integral of 1 over u du plus the integral of 1 over u minus 1 du. Now the integral of 1 over u, we know that it is equal to the natural log of absolute value of u. So this would be minus ln of absolute value of u, then plus ln of absolute value of u minus 1. Right. But if we go back, our u was set to be this. So this was the value of our u, if you remember. So we can just substitute back. So if we substitute back, we're gonna have minus ln of 1 plus e to the power x, then plus ln of 1 plus e to the power x minus 1. Now we can see that minus 1 and plus 1 cancel out, so this would give us minus ln of 1 plus e to the power x plus ln of e to the power x, absolute value. Now what we can do here, we can use the properties of logarithms, because if you remember, if the natural log of a over b basically would give us the natural log of a minus the natural log of b. So here in this one here we have something similar to this, so we can just write it down as a single natural log, and we're just gonna do the fraction. We're gonna write the fraction here. So this one, let me make it small. So from this formula we're gonna have the natural log of e to the power x, we put the absolute value, over 1 plus e to the power x, absolute value. Right. Yeah, but our goal was to show that this integral was equal to a, so we need to do something else. Now what we can do here is to let me see, we have this, okay, but as we can see, this was the indefinite integral, but we need to use the definite integral from minus a to a, right? So we need to come back to our previous exercise, which was this. So if we come back to this, right, so we're gonna have that this one is equal to a natural log of e to the power x over 1 plus e to the power x from minus a to a. We need to make these substitutions. So this would give us ln of a e to the power a over 1 plus e to the power a minus natural log of e to the power a over e to the power minus a, my bad, e to the power minus a over 1 plus e to the power minus a. Right, now we are in the same situation as this one here. We're gonna use the properties of logarithms, because we have ln minus ln, like here, ln minus ln. So we're gonna write it down as one single natural log, and we're gonna do this over this. So this one over this one would be this one times the reciprocal of this. So that would give us here we have absolute value, so e to the power a over 1 plus e to the power a would remain the same, but then we flip this because we're dividing, so it's like multiplying to the reciprocal of that one. So we're gonna have 1 plus e to the power minus a over e to the power minus a. Right. Now what we can do here, we can we do something here? We need to simplify. Yep, we need to simplify something. All right, cool. If we, all right, let's just write it down as a single fraction first of all to see things clearly. So we're gonna have e to the power minus a 1 plus e to the power a, and then we have e to the power a times 1 plus e to the power minus a. Right. Now what we are going to do, this e to the power minus a here, I'm gonna write it down as 1 over e to the power a. If we expand, all right, let's expand. So this would give us, we multiply this by this, then this by this, same thing. So we're gonna have e to the power a times 1 would give me e to the power a, and then e to the power a times e to the power minus a would just give me 1 plus 1. So on the numerator we're gonna have e to the power minus a times 1 would give me e to the power minus a, and then e to the power minus a times e to the power a would simply give me 1. So now it's nicer. What I'm gonna do, I'm gonna write e to the power minus a as 1 over e to the power a. So this would give me ln of e to the power a plus 1 over 1 over e to the power a plus 1, isn't it? Yeah. Now from this I would make the denominator to be e to the power a. So this would be ln of e to the power a plus 1 over, I put e to the power a to be the denominator, so I would have 1 here plus e to the power a here. Now this one divided by this is basically multiplying by, we flip it, we're gonna multiply by the reciprocal, right? So this would give me natural log of, here we have e to the power a plus 1 times, we flip this, so we're gonna have e to the power a over 1 plus e to the power a. Now we can see this one here would cancel out with this, and we're gonna be left with natural log of e to the power a, but a was positive. If we go back to the problem, a was greater than or equal to 0, so it simply means that here there is no need to put the absolute value, so we can just write natural log of e to the power a, which is a. And we can see that we have shown that this integral here is equal to a. Yep.